Okay, so we have done the bell work. Now we are going to, your homework tonight is going to be on the back. It is 1 through 15. You have to balance those, and you have to classify the type of reactions, which we're talking about today. Okay? So, there are 5 types of reactions, basic types. Not all reactions fall under these, but we have 5 that we're going to talk about in this unit. By the end of this unit, or by the end of this week, hopefully by the end of today, you should be able to tell me, you should be able to look at your reactants, say you have A and X, and you should be able to tell me by seeing A and X and telling me what type of reaction it is, to be able to classify it by looking at the reactants. Yes. Okay. Also, by looking at the reactants, you should be able to tell me, predict what the products are going to be. Okay? If I gave you BY, by the end of today, you should be able to tell me that that breaks into B and Y. Okay? I'm just using arbitrary letters here. So I have an element and an element making something. Here I have a compound breaking into an element and an element. So that is going to be what we're focusing on today.
Is it going to be harder than that? Is it going to be harder than that? Yes.
I mean, I like to think of this as dating. Chemistry is all about dating and chemistry. So without going to put it into context like that. So let's just go ahead and get started.
I'm not good at either of these things. Oh my gosh. Me too.
You know what? And that was just recorded. Everybody, that was... All right, synthesis. What does synthesis mean? To synthesize something. If you go and synthesize something, you make it. Okay, so you're making something. Or you're creating.
Wait, you're actually recording?
Yes.
I thought you recorded earlier in the day.
No. Okay. So what happens here is we have 2 reactants. All right, we have reactant A and reactant X. There's 2 of them, and it makes one product, AX. So what we're going to find out is that your reactants are in their elemental form most of the time, okay? And they come together and they make your compound. So in this case, we might have a metal in its elemental form, say magnesium, and it comes together with a non-metal. So a non-metal, say maybe nitrogen. Okay. And then they come together. And when they come together, we have a metal and a non-metal. What kind of bond does a metal and a non-metal make? It makes an ionic bond. Which means we have to look at what to make the formula? At their charges. So if I'm looking at here, barium and sulfur. Barium is a +2 charge. Sulfur is a -2 charge. So we get BAS. And then you go back and you have to balance it. And to balance it, I would put an 8 there to get my 8 sulfurs. And I would put, now I have 8 bariums, and I would put an 8 there.
S next to barium is just solid.
Yeah, just ignore the states of matter. It's exactly what we've been doing, except for now I've put some parameters where you have to be able to predict what's going to happen. So if I go to magnesium reacts with bromine, magnesium is my metal, bromine is my nonmetal, and we get this ionic compound being made. So we have 2 becoming 1. So think of it as you go to the prom by yourself, somebody else goes to the prom, they go stag, and then by the end of the prom, you guys leave together instead of leaving in separate whatever, okay? All right, so I like to think of this as marriage. They have 2 individuals and it becomes one bigger thing.
Wait, what?
Huh? Like a marriage. You have 2 individuals and you become one.
Oh, yeah. What happens if they get tired of each other?
We're going to talk about that next.
Is there counseling and chemistry? Marriage counseling?
Okay. All right, let's do some problems here. Rubidium metal, and solid sulfur. What is it going to make? It's just well, let's not even do the equation or the balancing yet.
So why are you marking up?
I just don't want you guys to focus on that. So RB has a charge of what? Plus 1. Sulfur has a charge of what? Minus 2. So what is the equation going to be? RB2S. All right, what we've been doing, metal and nonmetal. Now we go back and we have to balance it. I need 8 S's, which gives me how many RBs now? 16. Magnesium ribbon. 8 RB2S. So magnesium ribbon. Magnesium. What's the formula for magnesium? Mg. What's the charge on it? What's the formula for oxygen? O2. And what's the charge on oxygen? So predict what's it going to make. MgO. And then you have to balance it. Not MgO2, because Mg is a minus 2, O's a, or Mg is a plus 2, O's a minus 2. So they cancel each other out. Sodium. What's the formula for sodium? And chlorine gas. What's the formula for chlorine gas? Cl2. Sodium is a plus 1. Chlorine is a minus 1. So the formula is NaCl. And then you have to go back and balance it. Put a 2 there and a 2 there. Everybody good with synthesis? So anytime you see 2 becoming 1, you could, it doesn't have to always be elemental. You could have ammonia, which is a compound, and you can have hydrochloric acid, which is a compound, and it could make that. So two compounds come together and make a bigger compound. Okay?
Wait, that's synthesis too.
That's synthesis too. If you had 3 reactants making 1, still synthesis. Okay? All right, decomposition. So if something decomposes, what happens? It's breaking down. So now our happily married couple are going to break up. And we are going to break them into their component parts. So if you have 1 reactant, it's going to break into 2 or more products. So you're just breaking it down. And when you do this, what you really are going to do is just going to figure out what elements composes it and break it down into its elemental parts, its natural state. So if I have silver, solid silver oxide, I break that down into my 2 elements, which is silver, which is just an Ag, and then we have oxygen, which in its natural state, oxygen is O2. And then you go back and you balance it. So we need a 2 there. Oh, no. Put 2 there. And now that gives me 4 silver. So 2, 4, 1. Biggest mistake will be you will just go Ag2 and then O. You'll break it apart just like you see it, but you don't. You put it into its elemental state. So water. Break it down into its 2 parts. Water is composed of H2 plus O2. And then how do we balance this? Need to put a 2 in front of water. And now we need to put a 2 in front of hydrogen. So it's 2, 2, 1. Now when you break it up, you can break it up. You might write it O2 plus H2. It doesn't matter. It's the same thing. Questions? All right, so let's do some predictions. Potassium chloride. What's it going to break up into? K plus Cl2.
Where'd you get 2? So this is basically just balancing the equation, just writing the equation.
Yeah. The 2, because I bring clay for our new house. It's chlorine's diatomic, so it has to have that 2 when it breaks up into its elemental state. So then we go in, we balance that out. Lithium nitride. What's it break into? Li plus N2. And then to balance it, we put a 2 there and a 6.
And when you balance it, you multiply out by how many compounds or element you have. You get 6 from 3.
Yes. You have to distribute it out. The 2 distributes to everybody. All right. Silver sulfide breaks into, or aluminum sulfide breaks into what? Aluminum and sulfur. What's the formula for elemental sulfur? S8. So to balance this, I have 3 here and an 8 here of my sulfur, so I'm just going to multiply this one by 8 and this one by 3. Their common factor is 24, so we'll do 8 and 3. And what's that do to my aluminums? I have 16, so I'm going to put 16 right there. Huh? Big numbers. So we have one compound, and it comes into two elements. Y'all are pretty quiet. Everybody okay? Working these? Okay, so the next thing what we're going to do is we're going to talk about, so we've gotten two. We've got synthesis, and we've gotten decomposition. So now what happens is this time we're going to have what is called a single replacement, or if you go out and you're trying to figure out what you're doing, you might see it as single displacement. But what happens here is you have an element, and it comes in and it kicks out an element from the compound. So you have an element and a compound. That element, if it's a metal or a positive, if that element makes a positive cation, then it's going to kick out the positive cation in the compound. So, again, going back to dancing or whatever, if you want to, B is dancing with X, and by the end of the song, A is swooped in and is now dancing with X, and B's over there by themselves. Okay? So A comes in, and A kicks out B. So A is a metal in this case. B is a metal, and X is a nonmetal. So this metal comes in and kicks that other metal out. So we have a positive replaces the positive. You can have a negative replacing a negative. Most of the time it's going to be a metal replacing a metal, but sometimes special case is hydrogen. Hydrogen's a nonmetal, but hydrogen makes a positive charge. So sometimes you will see that. Okay, so here we have one element plus one compound, and by the end we end up with one new element by itself and one new compound being formed. So anytime you see element compound and on the other side of the arrow you see a different element by itself and a new compound, it is a single replacement reaction. Okay? Again, you have to look at, we're dealing with cations and anions, so you have to look at charges to get your new formula.
What does that say?
Look at charges to get your new formula. Look what?
No, it looks like woke charges. Is that
Oh.
at?
Look at, yeah.
Oh, okay, I see it now.
Okay. Chlorine and sodium bromide. Formula for chlorine is what? Cl2. Chlorine is a -1 charge when it hooks up. Sodium is a +1 and bromine's a -1. So the formula for that would be NaBr. So there's your starting point. Now you have to look and see, that's why I always put the charges up here. Look and see who is chlorine going to kick out in this equation. Why is it bromine? Because it's a negative. So negative and negative. So chlorine comes in and kicks bromine out. I guess I should make that arrow better. So you don't have to draw those arrows. I'm just doing it for visual sake. So now bromine is by itself. What's the formula for bromine? Br2 And sodium's a +1, chlorine's a -1, so the formula for sodium chloride is NaCl. And then you come back and you have to balance it. So we're going to put a 2 here and a 2 here. Okay? Yes?
There are two after
Bromine.
bromine.
I bring clay for our new house. Now, why did I not bring that Cl2 over here? Why wasn't the 2 brought over here with this?
Positive and negative.
Because we have a +1 and a -1. All right, the charges. We're looking at the charges now. Zinc and hydrochloric acid. Can somebody answer that? Zinc is going to kick out Illy. All right, zinc is a +2. So zinc is a +2, hydrogen's a +1, and chlorine's a -1. So zinc is kicking out hydrogen. When it kicks out hydrogen, who's all left by themselves? Hydrogen is now left by itself. And now we get ZnCl2. And then you go in and balance it. Okay? Element, compound. New element by itself, new compound. Questions? All right, let's do some examples. Iron and water. So right here, there should be some clarification that this is iron 2. So iron and water. So who is iron going to kick out? Iron kicks out the hydrogen. Now hydrogen is left by itself. And iron and oxygen hook up, and that formula is FeO. And you come back and balance it, and it looks like it's balanced to me. All right, iron's a +2, oxygen's a -2. So it's a 1-to-1 ratio. Magnesium. Formula for magnesium. Magnesium has a +2 charge. Lead has a +2 charge, and nitrate is a -1. So what's the formula for lead to nitrate? And then we need a 2 out there. PB comes in. Who's getting kicked out? PB is getting kicked out, right? We have a metal, and it's got to replace that metal. So when that happens,
Why is it it's not?
hello? Uh-huh. Uh-huh. Yeah. Uh-huh. I will. All right, thanks. That was for you.
What do I need to do?
So, like, at the last 5 minutes of class, go to CIS.
Oh, okay.
Okay, so we said that magnesium's coming in and is going to hook up with nitrate, and we end up with MgNO3 2, and lead is left out there hanging by itself.
Does it matter what order you do? Like,
No.
you have PB and
Doesn't matter what order you put it in. And the last one, chlorine. What's the formula for chlorine? Cl2. Chlorine's a -1. Potassium's a +1. Bromine's a -1. So the formula for potassium bromide is? KBr. So who gets kicked out? The bromine gets kicked out. So bromine is now by itself, Br2, and KCl. And then you come back and balance it. So I need a 2 here and a 2 there. Very good with that one?
Yeah.
Yes.
So the first, like the one that kicks out is always the first element, like Cl and then Mg and then iron. Like those are the first ones written and those are the ones that kick out?
You just have to look and see what's its charge going to be if it hooks up with something. So chlorine becomes a negative, so it's going to kick out the negative in the element or in the compound. Okay. Yes.
All you can work is like number 9, but when they get the elements get rearranged.
We're about to talk about that. Okay. So next, if you don't have a single replacement, if you have 2 compounds, what happens in a double replacement is those 2 compounds will switch partners. So the metal of one will kick out the metal of the other one. So A will now hook up with Y, metal, non-metal. And B, which is a metal, is going to hook up with X, which is a non-metal. So they just switch. The metals switch places. I always draw arrows because I can see if there's 1 arrow or 2 arrow. 1 arrow, I know it's a single replacement. 2 arrows, I know it's a double replacement. So what happens here is, and when I look at this, I always think of this kind of like the foil method. We have our outers hook up, and then you have the inners hook up. Okay? The only problem is you've always got to write the metal first and then the non-metal. So it's always metal and your non-metal. And then here, again, metal and non-metal. If you write it wrong, then I'm going to count you wrong. Because we should know by now that ionic compounds are metals than non-metals. So we get 2 compounds. And we form 2 new compounds. Again, you have to look at the charges when you're writing those equations so you know what is what. Okay, we ready to do some examples? Copper 2 chloride. So what I'm going to do here is I'm just going to go ahead and write the equation. Copper 2 chloride. And it reacts with hydrosulfuric acid. I like to write my charges at the top. So the charge of copper is a +2. Chlorine is a -1. Hydrogen is a +1. Sulfur is a -2. So in here we have copper hooks up with sulfur. And that formula makes what? We have a -2 and a +2, so it is just CuS. And then we have hydrogen hooks up with chlorine, and that gives us HCl.
So the substance that they already have don't really matter, it just matters what you're trying to do. So you just like, to balance it, you want it.
So to balance it, we would put a 2 there. Okay? So a couple more examples and then we're done. All right, barium chloride and sodium sulfate. So who is barium going to hook up with now? Sulfate. So we get BaSO4. Barium's a +2, chlorine's a -1, sodium's a +1, sulfate's a -2. And now sodium hooks up with chlorine to give me sodium chloride. And then you go back and balance it. Everybody good? All right, I'm just going to do one more. Let's go to hydrochloric acid and sodium hydroxide. Hydrogen's a +1 and chlorine's a -1, so the formula is HCl. Sodium's a +1 and hydroxide's a -1, so the formula is NaOH. So H hooks up with what? Hooks up with OH, so we get H2O or HOH. And Na hooks up with Cl, so we get NaCl.
Do you want us to write H2O?
I don't care how you write it. H2O or HOH, it doesn't matter to me. Okay, any questions? So on your homework, the only